Today we're reasoning through how aircraft speeds impact airport design without hesitation, repetition, or deviation, starting now. Aircraft speed is a fundamental factor influencing airport design, particularly in relation to runway length, orientation, and capacity. The speeds at which aircraft take off, maneuver, and land, collectively known as V speeds, are critical for determining the required runway distances and operational capabilities of an airport. The speed that pilots rely on during operations, known as indicated airspeed or IAS, is measured by comparing the dynamic air pressure due to forward motion with the static atmospheric pressure. This is particularly important because it affects lift generation and stall speed, both of which are central to safe takeoff and landing operations. True airspeed or TAS, which is the actual speed relative to the air, becomes relevant when calculating flight times and navigational data. At higher altitudes, indicated airspeed reads lower than true airspeed due to the reduced air density. For example, to account for reduced air density at 5,000 feet, one might add approximately 10% to the indicated airspeed to approximate true airspeed. This difference between IAS and TAS is significant for high altitude airports as it influences the aircraft speed requirements for takeoff and therefore the necessary runway length. Some key V speeds and their role in runway design are as follows. Number 1, we have VLO or the liftoff speed. This is the minimum speed required for an aircraft to safely leave the ground. Runways must be designed long enough for aircraft to reach VLO based on their performance characteristics and weight. Secondly, we have VR or the rotating speed. VR is the speed at which the pilot raises the nose for takeoff. If runway lengths are insufficient for reaching VR, aircraft may risk delayed liftoff, impacting safety. Thirdly, we have V1 or the decision speed. This is the critical speed at which pilots commit to taking off even if an engine fails. For safe operations, runways must be long enough to accommodate an aborted takeoff up to this speed, ensuring the aircraft has enough distance to stop safely if necessary. Lastly, we have VSO, which is stall speed in landing configuration, and VREF, which is the reference landing speed. VSO indicates the minimum speed needed to maintain lift in the landing configuration. VREF, which is calculated as 1.3 times VSO, is the target approach speed for landing. Runways must account for these speeds to ensure sufficient length for landing deceleration and safe operations. Higher speeds for larger or heavier aircraft mean that airports serving commercial jets require longer runways to accommodate their takeoff and landing distances safely. Additionally, higher speeds influence the spacing between aircraft for both takeoff and landing, impacting the runway's operational capacity. Airports must design runways not only to accommodate maximum takeoff and landing speeds but also support multiple operations per hour, maximizing throughput and minimizing delays. In conclusion, aircraft speed profoundly affects airport design, particularly in terms of runway length, configuration, and operational capacity. By understanding the different V speeds and the relationship between indicated and true airspeeds, airport planners can create efficient layouts that ensure safe and efficient operations for all types of aircraft, from general aviation to high-speed commercial jets.
If you like this video, don't forget to hit the like button, leave your thoughts in the comments, and subscribe for more aviation content.